All right, let's get started. Yeah, just keep this one here. Good to see everyone. Welcome to this next session here in this theater. My name is Jits Langedijk. I'm a senior solutions architect at NVIDIA, and I'm doing this presentation, of course, on behalf of NVIDIA, but also with our strategic partner Dell Technologies. So welcome also on behalf of Dell. So breaking down barriers in the hybrid workforce with Boundless VDI. Quite a title, of course. So this session will be about VDI, but especially on the more, demanding workloads, of course, as you can expect from NVIDIA. Let's see, yeah. But a little bit of introduction, of course, and especially what we have seen during the pandemic, but even before that, VDI and remote work has already been adopted and certainly has proven itself over the last couple of years. And certainly during the pandemic. But some recent studies, these are studies based on what Dell Technologies has done with their customers, so customer surveys, but also backed up these numbers with IDC and Gartner numbers. And what we have seen, of course, is that 40% of the workforce will continue to work remotely, and probably 100% of us today, right, working remotely. And over 50% will use the same device both for their private work as well as their business work. So the business consumer will merge into, or is already merged into, a single device. And over 70% claims that they are more productive when they're working basically remotely or working from anywhere. So certainly, as I said, working remotely has definitely proven itself during the pandemic, but even before that. So that's a little bit the baseline where this all gets started on. What we have seen at NVIDIA, of course, focusing on the more demanding workloads, the 3D accelerated workloads, is that there is another challenge there ahead. So first of all, we have teams of specialists in organizations or across organizations that are working together on different places on the globe, and they're all working with their own applications. So certainly these individuals that have a certain skill set and use their own specific tools in their daily work, whether that's 3ds Max or Unreal or Revit, Substance, etc. So these are really demanding applications when it comes to hardware acceleration in general, and of course specifically on GPU acceleration. And another big challenge that we have seen is that the data sets, they're becoming really complex, multiple layers, so it's not only an architect is doing the exterior of the building, but also already people that are designing like the plumbing or the electricity, etc. So everything and strength calculations all into the same model. And of course you can expect that this will bring some complexity when these workflows just basically blow up. So in order to make sure that we can facilitate those geographically disparate teams with their own set of applications. As I said, data gravity is a big problem here because you do not want to have data to be copied back and forth over maybe a WAN connection, working in different versions. You want to make sure that this entire process of an idea all the way to the realization of this idea, and especially when we're talking about architecture, for example, that this is not like a sequential process, but it's a parallel process, of course. You want to make sure that every change along this entire journey immediately is reflected to all the people that are involved in such a project. So in order to chase this single source of truth and bring all the data into a centralized environment, and of course many of you are already familiar with VDI solutions, this isn't really a big new thing, of course. However, with these 3D workloads, it is a big thing. And what NVIDIA has done is, and of course the metaverse is a big topic, also at NVIDIA, of course, for many years, and we created the Omniverse. And Omniverse is basically a solution that copes with all these challenges that I just tried to describe. So again, we have these individuals working from any place on the globe with their own set of applications, and they all need to connect to this single source of truth and all work in the same data set. And this is what we call the Omniverse, and this is basically what we call the component a nucleus instance that ties everything to everything, basically. We could only achieve this by making use of what we see here, the USD file format, Universal Scene Description. This is an open file format designed by Pixar, and Pixar designed this, this file format also to cope with these same challenges, and then they open sourced it and we adopted them and further developed it together with Pixar. So the engineer, designer, the creator, anyone using these specific applications, they can simply convert the information into USD and store this in the centralized environment. And this centralized environment is not just a data hub where everything is connected to each other. It's much more. It's a simulation engine. So it obeys the laws of physics, for example. NVIDIA physics is applied. The materials definition language, the MDL, is also based in there. So, of course, especially when you take all this different information and into a single view, whether that's with AR, VR, or just maybe on a screen, you need to make sure that everything is, well, accurate. Again, it needs to obey the laws of physics. So when someone designs something like a kitchen tabletop and you change the material from wood to metal, for example, immediately it has a different effect when it comes to bouncing light, for example. Wood, of course, or take a carpet, for example, it absorbs the light. Well, these kind of materials, they bounce off all the light rays. So what we have done basically in this tool, we made a simulation that is exactly the same as in real life. So everything that you can view in a viewport is basically the same as I said in real life. And even like gravity, it needs to obey the laws of physics. When you in a scene, you have a ball, and you place this ball somewhere on a sloped edge, and you hit play, it rolls down. So that's basically Omniverse, connecting all these people, connecting all these applications into a single location. And a little video to illustrate this is based on 3 individuals working with Unreal Engine, Substance Painter, and Maya. And there should be a video starting. Yeah, automatically, I hope so, or not. So on the left side, what we see here is, I really need to push it. I don't know what's happening with the video, but this is not as it's supposed to be. So I'm gonna try to explain what we will, well, I can share the video afterwards, but it's also available on YouTube. But what we will see is that 3 individuals all working with their different applications, as I said, Unreal Engine, Substance, and Maya from Autodesk. And as one individual only making some changes to the wall, you will immediately see that everything is will come together and will merge together. So everyone will see in parallel all their changes instead of like doing this in a sequential process, doing multiple iterations, making your changes, exporting data, importing data, etc. So that would be nice, of course, with a nice video. So together with Dell, as I said, our strategic partner for infrastructure, what Dell have done is they build up their little infrastructure, and in this case, instead of different applications, they use multiple instances of Maya from Autodesk, and basically connected those to the Omniverse. So you have a virtual workstation, you install a connector or a plugin, we call it a connector, and it makes it possible to connect to the Nucleus instance and to work together on the same data set. So, and there should be a video in here as well, so that's always the challenge where you're not using only using a USB stick and not your own laptop. So what we have done, or what Dell has done, is basically use a test, what we call NVIDIA NVector, and this is a test tool, not to test like the maximum user density or how much CPU is being consumed, etc. But it tests the end user latency, the frame rate, and the image quality. And why does this even matter? Of course, when you're increasing user experience with adding GPUs, and certainly for these applications, GPU acceleration is a requirement, but even though, you want to make sure that the user experience, is increasing. So we can measure this with NVector, NVector Lite in this case, and with end user latency, when we measure this, what we basically do is every keystroke, every mouse click, that's basically the starting point of our measurement. because you make a change, an alteration in Maya in this example, and that needs to be reflected back to a new frame on your screen, on your endpoint, whether that's a physical endpoint or in the test environment, a virtual endpoint. So there is some latency there. And of course, with adding a GPU, you want to make this latency as less as possible, because then you have a better user experience. Also frame rate, of course. With Blast, or I just assume that the majority is using Blast and maybe not PC over IP anymore. But with a remoting stack in general, you want to get as much as frames across the wire as fast as possible, but also with the best quality. So of course you can make some adjustments to crank up that number, and for those who are familiar with NVIDIA vGPU, because this is all based on a virtualized environment, of course, with different vGPU license types, there's also a maximum in the amount of frames that you can send over. So with a virtual PC, that's limited to 45 frames per second, and with the the RTX virtual workstation license, that's well, in essence 120 frames. At least that's something that we can do. I think with VMware Blast, maximum is with 60 frames per second, but that's usually enough for this kind of workloads. 60 plus, of course, becomes important when you're doing remote virtual reality or extended reality. And another thing, of course, when you're using a video transcoder, you encode all the frames that you send across the wire to the endpoint device where it needs to be decoded. You will lose some quality in the image. So again, with GPU acceleration, we try to decrease that image quality, or basically we try to increase the image quality as much as possible, as you can understand. So let's see if this video will play, because our friends at Dell made a great video about what they have created. Yeah, this one runs. So thank you, Dell. So basically, this is the test environment where they created a couple of instances, virtual machines. So they use a 3 gigahertz CPU, and the reason for that is, or at least why we always advise to use a 3 gigahertz clock speed CPU or more, is because a lot of these 3D accelerated applications, okay, they have a lot of single-threaded processes, or some of these applications are completely single-threaded. And of course, you can put as much vCPUs in those virtual machines, but yeah, if the application or the process only uses a single thread, then yeah, there's no real benefit. So that's why we always advise to use 3 gigahertz or more. So the Nucleus virtual machine stores all the data, and we have 2 virtual machines that will be running the workload, in this case Maya. Let's see if that all succeeds. And as I said, in order to make sure that these 2 individuals using Autodesk Maya connect to this Nucleus instance, we have to install a plugin, and this is the connector, as we call those. And these connectors, of course, they come in different flavors. For Autodesk Maya, we have a connector available that allows you to do live sync, and also bidirectional. So it exports all your changes and also imports the changes that someone else is making, of course. So it differs a little bit from applications where it's a unidirectional or a bidirectional connector that we have available. So we have an NVector light test, and with this NVector tool that we provided to Dell Technologies, they are able to run a predefined workload, what we call the knowledge worker workload, using some office productivity applications and some multimedia applications, of course, browsing some multimedia content. And then we will measure the end user latency, the image quality, and the amount of frames that successfully will be displayed on the client device. And eventually that turns out into a nice document, a PDF, that will display all the results. Yeah, in the interest of time, I will, let's see if we can quickly go to the last stages here. Yeah, so we conducted these tests, or Dell Technology conducted these tests, and what we have seen with end user latency, both what we measure with the knowledge worker, the KW, the end user latency, 141 milliseconds. Basically with Maya, which is a, well, more demanding application, of course, we have an even lower end user latency, so an increased user experience. And what we also have seen in the next slide, is the image quality. So, of course, in the image quality, the degradation is, well, there is some slight degradation, of course. When it's exactly one, then it's exactly the same image. So we have a slightly degradation with all the content that is being displayed. And of course, you can understand when there's an image in a wireframe and you're using a video codec, for example, over a bitmap codec, then that will be challenging in order to encode and decode on the client device. And now I'm experiencing some latency. Yep, sorry, that goes too quickly. So on this last slide, basically the end results of what Dell Technologies have tested with nVector Lite, with the infrastructure that they have set up, with a different workload than we usually do with the KW workload, but especially now in this example, a workload that represents the 3D accelerated applications. And as we have seen, the image quality, the end user latency, but also the amount of frames that successfully comes across the wires is really good and provides a good user experience. So certainly a good use case to provide these kind of workloads in a virtualized environment. And with that, I'm already over time. I want to thank you all, and I wish you all a great Explore this year. And if there are any questions, feel free to reach out to me. I'll hang around in the exit and make some room for the next presenter. Thank you all.